Hello, so I've been given 4 points, O, A, B and C, and I've been told they form a parallelogram, O, A, B, C. I use a scalar product to find the acute angles between the diagonals of this parallelogram. Okay, well let's just make sure we understand, we're all on the same page, let's make sure we also understand what these coordinates mean in 3 dimensions. Okay, so if I was just given 2, 8 for example, the coordinate 2, 8, that's my x, that's my y, okay? So if I draw that on an xy axis, here's my x-axis, here's my y-axis, what that means I move 2 across, I move 8 up, so I end up at a point up here somewhere, okay? If I add a third point in here, or a third coordinate in here, I guess it's called an ordinate, that is my z coordinate. So what that means is that x is how far I move left and right, y is how far I move up and down, z is how far I move forwards and backwards as well. So forwards and backwards, okay? So if it's 2, 8, 2, that's my point A, it means I move 2 across, 8 up, still doing the same thing, but this time I move 2 out as well. So I kind of end up at a point sort of suspended in space, if you can visualize that. So it's sort of in front of the XY plane, sort of. Anyway, so yeah, that's what it means. But actually, we don't need to really worry about, visualizing where A, B, C is, because O is obviously the origin, it's obviously down here. We don't actually need to worry about where A, B and C is in kind of the position of this kind of X, Y, Z plane, because we as mathematicians are very clever. We label parallelograms in a very, very special way, or label any shape, in fact, in a very special way. So I've been told it's O, A, B, C. Those are what I'm calling the corners, or the vertices of my shape. But I don't just label them randomly. So like, I don't just say that one's O, that one let's just make it A, let's just make this one B, and let's just jump over here for C, for example. I don't label it like that. We always go round, almost like a clock. We can either work clockwise, or we can either work anti-clockwise. That's the only discrepancy, but we always work round. So if we go from A, then this one up here would be, if we go from O, this one up here would be A, then this one over here would be B, look, I'm working sort of around like that, then this one will be C, okay? So that's how we label them, so we don't actually need to really visualise this. Well, I guess we kind of do, because we need to know which way they've labelled them. Have we labelled them this way round, sort of going clockwise, or have we labelled them going this way round, so kind of going the other way as well? Well, look, it's not that difficult to see, okay? 2, 8, 2 is a point over here. 5, 5, 8, well, 5 is going a little bit further across, not as far up, but we're going further out. So B is out here, okay? And then C, you can verify. Well, look, we move 3 across, we then move 3 down, there's your clue, okay? Then we move 6 out, so it's going to be a point down here somewhere. So actually the parallelogram sort of looks like that. So we're actually going round clockwise. So I can say this is A, this is B, and this is C. And that's always how they'll label them in the exams, okay? Because examiners are proper mathematicians, trust me, they will label your shapes properly. They won't throw a curveball in there. They have to label them like that. They've got rules they have to follow by. They will always label them in a sensible way. So working clockwise or working anti-clockwise going round. Okay. We've been then told that we need to use the scalar product to find the acute angle between the diagonals of the parallelogram. So here's a diagonal, okay? And I guess here's another diagonal. And we've been asked to find the acute angle between them. Well, are you happy that this is the acute angle? Okay, they're the same both sides, doesn't matter which way I'm looking at it. It's just geometry, that is. So this angle over here is the same as this angle over here, okay? Why is it that angle? Well, are you happy that these angles in here, they're also the same? They're obtuse. They're bigger than 90 degrees. So therefore, these aren't the ones I'm interested in. Okay, so I can think of each diagonal as a vector. Because remember, a vector is just a movement from one point to another. Okay, so if I just draw this diagonal out, the blue diagonal, that's moving from O, up to B. That's moving from O up to B. It could also be moving from B to O, it doesn't matter. Okay, but let's just say it's moving from O to B. Okay, and then likewise, let's just take this purple diagonal, so this diagonal down here, well, are you happy that's moving from A to C? Okay, it could also be moving from C to A, but let's just take it to moving from A to C. Okay, and all I've just literally done there is I've just taken those two diagonals and I've put them end to end. So I've picked those 2 diagonals up and I've just stuck them end to end. Okay, and the starting point has to be the same with both of them. Actually, in this case, it doesn't matter, but because it's an easy fix. But that will give me the angle between the diagonals, because obviously I can slide them about however I want to slide them about, and they'll always give me the same angle between them. Okay, so okay, these are the 2 vectors I need to look at. So the question is, what is O to B? What is O to B? Well, O to B is called a position vector, because a position vector moves me from the origin to some point. Okay, and fairly obviously, because you know, the coordinates of B, 5, 5, 8, literally mean I move 5 across. Well, where am I moving 5 across from? I'm moving 5 across from the origin. Then I'm moving 5 up. Where am I moving 5 up from? I'm moving 5 up from the origin. I'm then moving 8 out. Where am I moving 8 out from? I'm moving 8 out from the origin. You get the idea? Okay, so we call any vector that moves from the origin to a point a position vector. Okay, so in this case, OB is just literally the coordinates of B. Okay, as I've just shown you, we're just moving from the origin to the point B by moving 5 across, then 5 up, and then 8 out. Okay. Notice as well that I've written as a vector like this, like the coordinates we tend to write sort of horizontally, okay, sort of like that. But the vectors we tend to write as a column, sort of like that. Okay. And it's literally read in the same thing. Just think, well, we always read from left to right, and we also read, so think about reading a book. We always read from left to right, so X, then Y, then Z. Okay, and likewise, when we're reading a book, we read from top to bottom. So if you're not sure about what order, which one comes which in, okay, we always read from book from top to bottom. Okay, so therefore the X comes first, the Y comes second, and the Z comes first. So 5, then 8. So what about A to C then? What about A to C? Well, A to C is literally moving from A to C. So if I draw this out in kind of position vector notation, okay, here's my point A, here's my point C. I want to find out what that is. Okay, let's draw it on with a sort of an axis, let's just say. Okay, so this is my point O. It is in 3 dimensions, but I just want you to visualize it through. Okay, because it's the same thing. So this would be the position vector to A, okay, from the origin to A. This would be the position vector to C, okay, from A to C, okay. So I'm going to call this little a, and I'm going to call this little c, okay. Position vector to A is little a, position vector to C is little c. And then all we have to do is to get from A to C, so we're starting here, I'm going to draw in a different colour, we're starting up here, okay. We then have to go down this one, okay, so we're going backwards along A. That then is going to become negative A, because if we're travelling backwards along it, we're travelling in the opposite direction, so it's negative, okay? And then forwards along C, okay? So to A to C is going to be negative A, then we're moving along C, okay? And we tend to write it then as C minus A, just to write it with the positive first, so C minus A, okay? So between any two vectors, we just have to go the first one first. So A to C is just going from C minus A. Okay. So what is the position vector C? Well, it's going to be 3 minus 3 and then 6. Just write that a bit better. Okay. Subtract A. Okay. So remember that's subtract A. So that's going to be 2, 8, 2. 2, 8, 2. And then we just simply go, well, what is 3 minus 2 first of all? So what is 3 minus 2? Let's do the first two together. So 3 minus 2 is just 1, okay? Then we look at the second two. So what is negative 3 subtract 8? Well, negative 3 subtract 8 is minus 5, yeah? If 8 plus 3 is better way of thinking about it, go for it. Okay, so negative 3 minus, oh no, negative 3 minus 8. I've just fallen into the trap. Careful with your negatives. Negative 3 minus 8 is negative 11, isn't it? Okay, and then let's go 6 minus 2, so that is then 4, yeah. Okay, so that is the vector from A to C, and then we use the dot product on that. So remember what the dot product is. It is just simply saying the dot of A and B. So we just multiply each element together of A and B over the modulus of A times the modulus of B. So what that just literally means is the modulus of A is just simply saying, right, we just simply work out what was Pythagoras on this. So the modulus of OB is just going to be 5 squared plus 5 squared plus 8 squared and then square rooted. Okay, so stick that in a calculator. It comes out as square root of 114. Okay, and let's do the modulus of AC then. Notice as well that I'm just using A and B because this is what we use in the formula. This A up here is a different A to the A using down here, for example. It's just the two vectors that I'm interested in. So two vectors I'm interested in are OB and AC. Okay. So what is this? What is the modulus of AC? Well, it's just going to be 1 squared plus negative 11 squared plus 4 squared square rooted. Okay. So let's have a think what that comes out as. That's the square root of 138. Okay, then the question is, what is a dot b? So I'll get rid of this now. What is a dot b? So what is the modulus? So what we take these two vectors, so 5, 5, 8, and we dot them with 1, minus 11, and 4. Okay, what that just simply means, we multiply each element together. So we multiply the 5 and the 1 together to get 5. Okay, then we multiply 5 and negative 11 together to get negative 55. Okay, and then we multiply 8 and 4 together to get 32, and then we just add all those three things that we get together. So we just literally multiply the two elements together, two corresponding elements, so first with first, second with second, third with third, then we just add them all together. Okay, and when we work that out, that comes out as, well, that's negative 50 plus 32, so that is negative 20, negative 18, isn't it? Negative 18. Okay, we then stick it into this formula, so cos of theta, the angle between them, is going to be a dot b, which is negative 18, over these two things squared, so square root of 114 times by square root of 138. Stick that in a calculator. Remember, we want theta, so we take the cos inverse of that, and that comes out as 98.25 degrees. Remember, if they don't say, either leave it to 3 significant figures or 2 decimal places. Now look at that. We've been asked to find the acute angle. Now what we've accidentally done is we found the obtuse angle. Okay, so I probably made a mistake somewhere with sort of where I was positioning them as such. Like, it's no big deal. Okay, I just know that those two vectors, when I sort of add them together, so here are my two vectors. Okay, so here's my obtuse angles, which I didn't want to find, but I have accidentally because it's greater than 90 degrees. Okay, but I'm just interested in that kind of thing going on. So I'm just interested in, let's just have a look here. So what I've done then, if I just get rid of that, what I've accidentally done then is I found this angle down here. Okay, I wanted to find this angle down here. Well, because they're on a straight line, all I have to do is just 180 minus that answer, and that will just give me the answer which I'm after. So 180 minus my answer. Okay, and that comes out as 81.75. I'm going to leave it as 81.2 degrees. Okay, so that is the angle which I actually wanted, 81.2 degrees. But you see, I kind of deliberately made that mistake. Honestly, I did. Because I wanted to show you how you could get back, just in case you made a mistake.